Let me get my stuff in order. All right. Promise this will not be a death by PowerPoint. PowerPoint's only a small portion of this. So thank you everybody for showing up. My name is Mark Phillip. I work for a company called Studica. We are an academic reseller. We sell software to educational institutions, middle school, high school, colleges, universities. What I'm going to be talking about today is interactive design, or better known as game design, and kind of its role and how it fits into STEM education. Of course, nowadays STEM education is the big thing. It's like the buzzword for schools. There's a lot of funding in STEM. A lot of the administrators are only looking to fund STEM curriculum in the coming years. So we felt that it was important to sort of drive home the point about how game design is sort of the all-in-one solution to STEM. And basically what I'm going to be presenting here is, why I think that, and try and make my case for that. And I'll be talking about some of the tools that are used for game design. I'll show you a little bit of the software that's involved with a quick demo. And I'll talk about some of the new stuff that's being worked on the horizon as far as what kind of standards can be addressed by game design, curriculum standards such as Common Core, and then kind of the sort of curriculum that's being developed to sort of meet these standards for game design and Common Core. So if you need to contact me for any reason, there's my email, markp@studica.com. I'll repost that later in case anybody wants to follow up or has any questions. You can see our website at studica.com. So what I want to first talk about is the software industry, the entertainment software industry in general. Now, entertainment software is basically what video games are. Game design is starting to be used in more areas, and I'll get to that in a minute, but when we're talking strictly video games, we're thinking, The Legend of Zelda or Call of Duty or Grand Theft Auto, sort of those kinds of franchises is what make up entertainment software. So some of the numbers I want to throw out here are that consumers spent $24.75 billion on video games and all their associated hardware and accessories in 2011. That source comes from the Entertainment Software Association, which is basically the industry kind of entity that looks at all these statistics and data and compiles them together. And as of 2010, 67% of households US households owned a dedicated video game console or device. When I ran those numbers from the Census Bureau on how many households are in the United States, 67% of that is roughly 76,916,000 homes. So that's a very significant market that can be tapped into. And then this last stat is as of 2009, the industry employed roughly 120,000 people with an average salary of $90,000. Now, last I had heard, and I don't have the exact number on it, that number was expected to be over 500,000 employed, I think, as of this year. So my point about all these numbers is that, the game industry itself is a gigantic beast at this point. It is a multi-billion-dollar industry. It's employing a lot of people, and it has a gigantic market where they're pulling in significant revenue from. So, games are no longer what they were, say, back in the 90s or the 80s, where it was kind of this niche thing where very few people actually were involved in it. Very few people actually consumed games. It is now a very, very mainstream thing. It's surpassed Hollywood in terms of box office ticket sales. And because of that, it's something that more and more people are starting to want to push in education to prepare students for a career in the game industry. It's no longer the sort of thing you laugh off or brush aside, because there's actual serious money involved there, and there's some really good work coming out of the industry. And what I was talking about earlier, when we talk about other industries where we're seeing game design being used, this is a concept known as gamification. As defined by Wikipedia, I know that's not the greatest source, but gamification is the use of game thinking and game mechanics in a non-game context in order to engage users and solve problems. Basically, you're using game design theory and knowledge to engage users or customers in a different way across a broad spectrum of industries, rather than just saying, oh, I'm going to make the next Call of Duty. We have people thinking, how can I design a game that's going to help me in my chemistry research or my physics research? Or how am I going to design a game to market my product to my customers better? In a couple areas we're seeing this is, say, in architecture. We're seeing a lot of commercial firms are starting to use game engines to manipulate their designs in such a way that you can do interactive walkthroughs. The fact that game engines are integrated with the industry standard software like Revit and AutoCAD just makes this process very seamless. And I have an example of this that I'll show you real quick. So this website I'm on right now is arcvirtual.com. These guys do some really cool stuff. They're some of the only people I know that are actually messing around with virtual reality and architecture. I won't quite go into that, but what we have here is a scene that they developed inside of Revit, which is an architecture software. It's quickly becoming the industry standard. It's also made by Autodesk. They designed this building and everything in Revit, but what they did was they brought the model into Unity 3D, which is a game engine that I'm going to be talking about more as we go in. And what I can do here, you have this kind of GUI on the side where you can play an animation, you can turn landscape on and off, so on and so forth. But what I like to look at is I can enter the scene. And basically what ends up happening, I get this sort of first-person view, and I'm inside of their design, and this was all built inside of Revit. This was not done in a game engine. They just brought the model into Unity, and what they did was they created a script that allows you to actually walk around this house and kind of look at things. Now, the renderings themselves are kind of blocky. They're not too high quality in terms of, you know, textures and shading and stuff like that, but these are all things that you could, you know, if you wanted a really photorealistic kind of render, you could pull that off. It's just a little bit more work. So this is kind of one area we're seeing gamification in, say, architecture, and this is increasingly more and more firms are starting to do this. I mean, my brother actually works for a firm. He has a master's in architecture, and his firm's starting to pick up Unity 3D and Revit just for this purpose, so that they can, you know, go in and make these sort of walkthroughs and present this to their client. And what's also cool about this, and this specific demonstration doesn't have it, but you could script almost anything you want because a game engine gives you the programming at your fingertips. So if I felt like, you know, if I was designing this model, or sorry, if I was working on this within Unity, you could even do something like when your character walks up to this wallpaper, you could press a button and have it change the wallpaper on the fly, just so you could get a better idea of, you know, what you might want in your house here. So that's just kind of one area that we're seeing gamification, and that's just kind of a simple example. So let me get kind of back to this. Other industries we look at would be TV and film. Now this is a sort of kind of a newer realm, and it's still a bit experimental, but there's this kind of phenomenon known as machinima. And machinima is basically using game engines or game technology to script and, how do I want to put it, perform like a TV show or a movie. And kind of the best example I can think of this is this web series called Red vs. Blue. It's been on the internet, I think, even before YouTube was around. But what it is these guys who made it, they took the Halo game engine from Bungie's game Halo that was originally on the Xbox. They took the game engine, and what they did was they would just script their characters kind of moving around in the different game environments and interacting with each other, and they just overdubbed like voiceover comedy dialogue, and it's just this sort of comedy show, and every episode's like 20 minutes long or something like that. And over time they've gotten like millions of fans over time. I mean, anybody who's a gamer knows who Red vs. Blue are at this point, and that's just kind of one area we see it. Let me move forward here. Talk about more industries here. We see in marketing more and more people trying to engage with game content, and one example I have here is from the vegetable distributor Green Giant. They a couple of years back, they had done an advertising campaign where whenever you purchased a Green Giant Green Giant product, not vegetable, but any other products, you would be able to redeem points for the game Farmville. Now, if you don't know what Farmville is or was, Farmville is a very popular Facebook game where you basically, it's like a simulation where you make a farm, you grow crops and like, you know, harvest the crops, so you get points and stuff. The game has like an in-game currency that normally you would have to pay real money to get. But with Green Giant, what they were doing is when you bought their product, you would automatically get a code where you could redeem points within Farmville to then use in the game. Now, when they had done this, what the graph here is basically showing is market surveys of the reaction of consumers, whether they had a negative, neutral, or positive reaction to the sort of marketing that they were seeing. And overwhelmingly, Green Giant on this graph had the largest positive review once that occurred. They actually saw a boost in their sales, and it just made their brand awareness that much more powerful, even over some of these giant companies like Coca-Cola or DreamWorks, Microsoft. So it really worked out for them. And that's kind of, I don't know if I would call that directly gamification. It sort of is, but other areas I can think of as far as marketing goes, the Adult Swim network, well, not network, but the Adult Swim segment of TV programming on Cartoon Network, you know, the one that shows like Family Guy and American Dad and stuff late at night, they've kind of adopted to this pretty heavily. They actually have an Adult Swim production studios for video games where they implement a lot of their different iconic characters and stuff from their TV shows, and they offer these for like free on their website or through the App Store for iPad and Android. And it's sort of just another way for them to kind of drive home their brand awareness and sort of develop loyalty amongst their viewers. I think even like Mountain Dew and stuff now are starting to, you know, on their website, they're putting these kind of HTML5 based games on their site. And it's just, you know, they're not the most complex games. It's not like Call of Duty or Grand Theft Auto or something, but it's still a way for them to engage, you know, their market and sort of drive home their brand awareness. Social media is, in my opinion, a great example of gamification. If we just look at Facebook, the whole site is kind of gamified in a way. When you really look at the whole ability to share content, the ability to like content, and things like that, it almost encourages people to try and create content that they know is going to be viral just so they can maximize how many shares and likes they get. In a way, that's almost like keeping score in a game. And it's very derivative of sort of how games try and hook players by giving them a high score to go after, by making an achievement that they need to go after. And even beyond just the way Facebook works in general, we look at how Facebook's platform allows developers to create content within it. So you look at like, there's all these games on Facebook. You got like Bejeweled Blitz, the gangster games, you got the Farmville, you know, I don't even know. There's so many different games on Facebook. All your friends who are trying to invite you to play games that you get annoyed at, I mean, all that stuff is being made by random developers. And the whole point of that is to keep people using Facebook. You know, Facebook loves that they have developers creating games like Farmville, because the more they keep people hooked on Facebook's platform, the more money Facebook pulls in through ad revenue. So even though Facebook may not be making Farmville and Bejeweled Blitz or Puzzle Quest or whatever, they don't care, because the developers are going to be making their own money through their microtransactions, and Facebook's going to be keeping their users attached to their platform, absorbing their content and making their advertisers happy. So, you know, that's one case of it. You could even look at other social media sites such as Reddit, which isn't exactly social media in a way, but Reddit has an upvoting and a karma system where, you know, people who post good stuff, they get upvoted to the top of the page. People who post dumb stuff or stuff people don't care for gets downvoted. If you post good comments, you get positive karma. Stuff like that. Like, all of these ideas kind of harken back to video games and the way that games have hooked people over time, and these concepts are now being applied to a lot of these platforms. One thing I thought was really interesting is how games are being used in research. There's a game, when was this? 2010, I think, called Folded. Actually, this game's still alive, and you can download it and use it right now. But what it was, or what it is rather, is a game it's a puzzle game that's used for biochemical research. Now, it's developed by the University of Washington by their biochemical department, but they also worked with their Center for Game Design up there to make this. And basically what it is a series of puzzles where you have to fold proteins into the most efficient shape possible. Depending on how you fold the proteins, you get a higher score or lower score. Now, the game had like a leaderboard, and all these different users who used it would try their hardest to fold these shapes the best they could to get the highest maximum score. The game itself is actually programmed in real-world physics, and it's programmed based on the knowledge that we currently have about biochemical processes. So it was a very big joint effort between these two departments at the school. What ended up happening in 2010, and this had made some front page news, I think, in like the New York Times and Washington Post, a couple other publications, the people who are running the game, they will put out challenges every so often where they'll give you just kind of a strain of random protein shapes, and they'll say, figure out how you have to fold this to make it work. And they ended up putting one out there that was part of an HIV strain that had not been accurately imaged yet. They'd been working on it since the 80s, but nobody had actually been able to figure out what the shape of this particular strain of HIV was. By throwing it on to fold it, a couple hundred users worked at it over like a week of time, and eventually they actually figured out what this protein shape was. And when the data was given to the biochemical people in their department, they cross-checked it, they actually replicated it all in the lab and everything, and they found out that it worked, that these people using Fold It had actually just found out what this strain of HIV, what its protein shape looked like. So in that way, gaming was used to basically assist chemical research. We also see it happening in physics and stuff currently, where we have supercomputers running these kind of sandbox models of the universe to try and determine what were the conditions like after the Big Bang, or what would happen if a comet or if an asteroid of the size of Texas ran into the Earth at this trajectory and blah, blah, blah. They'll be able to have all the software process all this information and stuff. So that's kind of how we're seeing it used in research, and there's just more and more stuff coming out that people are using it for. So as far as gamification goes, that's something that's continuously getting bigger and bigger, especially as games become more widespread and more people are learning game design, game theory, and the programming behind it. We're seeing more and more people hop into these different industries and apply those skills there. So kind of lastly, what I want to throw out here is the whole STEM education angle. So I've talked about how the industry is big, how it's grown, how there's money, how there's jobs there, which is all good for your students. Talked about how gamification is diversifying the application of game design, which is great for your students. But then the million-dollar question is, how does this fit into STEM? Because more than likely, the people paying for your budget want to know that exact question or the answer to that question. So when we break down STEM, we got science, technology, engineering, and math. It's my opinion that game design satisfies every one of these criteria in some way, shape, or form. When we look at science, game design is heavily rooted in computer science. You simply can't make a game without programming. You have to program. And if you're going to be learning game design, you have to know some level of programming. Even if you're just going to be like the game designer, the guy making the story, it's still beneficial for you to understand at least the entry-level concepts of programming in C++ or C# or even BASIC or whatever programming you want to use. Also in the sciences, you have physics. Most modern games are using 3D graphics, and most modern games use some level of a physics engine. And in order to actually create a semi-realistic game, you have to sort of understand certain physics concepts. You have to understand, when my character moves forward, how do I calculate that momentum? How do I calculate the impact of this explosion hitting the rock on the ground in my game? These are all things that you have to work through and figure out and problem solve that. Tons of math, yeah. Game design is involved with tons of math, and it just goes hand in hand with computer science and physics. Like, in order to program, you have to be pretty proficient with mathematics, and you have to sort of develop a way of logically thinking through problems. And a lot of that just comes right back to math. And so if you're going to be designing games, you do have to engage in the maths quite a bit. And that can be something that will actually turn a lot of students off, because a lot of students are really intimidated by math. But in my opinion, I feel like programming can sort of, or game design and programming can kind of engage them in the maths in a way that they might not have thought about before. When we look at technology from STEM, this is a really easy sell for game design. I mean, to develop a game, you're directly involved with technology. You're working directly with computers. Oftentimes, you're trying to debug your game so that it runs on a variety of hardware platforms. So you're having to understand how the code you're writing is interacting with your graphics card, how it's interacting with your CPU and your RAM. You know, how much, even down to like, is this going to put too much strain on my processor, which is going to cause my computer to heat up, which is going to cause my fans to spin louder and overheat. I mean, these are all things that people have to consider when you're designing a game for, you know, for real. The other thing is that game design is one of, in my opinion, it's one of the few kind of software realms that's really pushing new hardware. We kind of saw this with Nintendo when they made the Wii back in, 2006, I think it was. Everybody thought they were crazy. They're like, oh, you know, a motion controller, that's not, nobody's going to want that. But it ended up being the biggest selling console. It beat out the Xbox and the PlayStation at the time. So, you know, it was huge. And that was kind of a new thing, using accelerometers. And then a couple years later, we kind of had the smartphones come out. And they were using the touch screens, the accelerometers, they had GPS and location functioning. And games were one of the first to be there, making new applications for those platforms, you know. Think of all the games that are on your smartphone and your tablet that are using the touch screen as an integral piece of that software. We're even seeing now with virtual reality, there's the Oculus Rift that came out that Facebook bought up for, what was it, like $1 billion or something ridiculous. Virtual reality is directly connected with video games. I mean, when you think of virtual reality, that's kind of what you think of first, is that you're in a video game setting, you know? And again, video games are some of the first adopting that. The Unity engine has Oculus Rift support, and people are already developing virtual reality applications for it. So I think as far as technology goes, that's a very easy to sell for video games, or for game design in general. Engineering, in my opinion, is the hardest sell when you're talking about whether or not game design fits into STEM completely. Mostly because games are just software, and while there is some interaction with the hardware, it's not like you're doing a whole ton of engineering to design a game. But I still think you can make a case here. When I marked down electrical engineering here because I feel if you want to truly make a game that runs efficiently across multiple hardware platforms, I feel that having a small understanding of electrical engineering and how the hardware within your computer is working with itself, I feel like that can only help you design a better, more efficient better, more efficient game for these different platforms. Audio engineering is one I bring up, even though it's kind of a different field. With modern games, more and more we are seeing high-end audio assets being created for games. A lot of these AAA titles that are being developed by EA and stuff, you know, they've got professional sound designers and audio engineers working on it, designing the sound for it and implementing them into their game. If you want to be a game designer, or if you're interested in game design, it's kind of important for you to at least understand the basics of, you know, what's the difference between 44.1 kilohertz versus 48 kilohertz? What's the difference between 16-bit and 24-bit? You know, how can I manipulate the wave of this sound to get a certain desired effect that I want within my game? Things like that I feel you can make the case for. And then in general, understanding of engineering concepts can help you create more realistic scenes. And this kind of goes back to what I was talking about with physics, where if you are going for realism in a game, you know, you don't want people to be brought out of your game because something looks ridiculous or behaves improperly. So if you're making some kind of war game or something, again, use like the Call of Duty reference just because it's popular, everybody knows what it is. Say you have like a bridge in your scene and you have some planes come over and they drop a bomb on the bridge and it blows up. You know, if you want that to be realistic and you want to immerse people in that realism, you're going to need to make sure that when you're programming that sequence, that when those bombs blow up, that bridge is crumbling and exploding outwards in a way that is consistent with real physics and real engineering. And I feel the only way you can do that is to sort of understand the concepts behind how is that bridge engineered, what are the physics behind that, you know, the engineering on that bridge, and then you can better manipulate that within your scene. Mathematics is the last part of STEM. I kind of talked about that in the beginning. You've got physics, you've got computer science. I mean, fundamentally, game design is involved with math. Again, it's a crucial part. If you're going to engage in game design and programming, you have to know math and you have to continuously apply mathematics when you're doing it. The last part of STEM is you sometimes hear people talk about STEAM, which is the same science, technology, engineering, and math, except they throw art in there. I even say that game design has the case for art, and there's still somewhat of a debate whether or not games are art or not. The Supreme Court of the United States seems to think so, but there's still some people who don't tend to feel that way. But when you look at modern games, you have so many assets. If you're in a 2D game, you have 2D images, which are sprites, which are usually created in like Photoshop or GIMP or something by some kind of designer, some kind of artist, and then they're given to the the game designer to implement into their game. The 3D models coming from Maya, Max, Blender, Rhino, whatever different modeling program you use, I don't think there's any argument that that's an artistic discipline. I mean, you look at some of the stuff Pixar's doing or DreamWorks Pictures are doing. I don't think anybody argues that what Pixar does is not art, you know? And so 3D modeling and stuff like that definitely falls into that criteria. And to make a modern game, you have to have these kinds of assets involved. So even if you yourself are not the 3D modeler, it definitely helps you to sort of understand the concepts. You have to know what a mesh is. You have to know what textures are, because these are things you have to apply and manipulate within your game. We can also look at musical composition. Most modern games have a soundtrack, and that means somebody had to write, record, produce that, and give it to the game designer to use as an asset within their game. You have voice acting in a lot of modern games. That goes along with acting, which is considered art. You have level design, which, sorry, my voice is going out on me. You have level design, which is kind of the same thing as 3D modeling, but in general, I consider that to be an artistic thing too. You have to design the level that you're on. This means you have to create vivid landscapes. You have to create a surreal landscape or a realistic landscape, whatever you're going for, that takes some level of imagination and creativity. And then the last one that I kind of write down here is cinematography. In a lot of modern games, there's a lot of emphasis on cutscenes, and within these cutscenes, they're all pre-scripted with certain camera motions and with specific lighting to make the scene look good. This all falls under cinematography. I mean, when you look at the credits of some of these AAA titles that come out these days, they have cinematographers attached to them. So I definitely feel that games also satisfy the art aspect of STEM, or STEAM if you want to go there. So the only reason I talk about this is because I've had people in the past tell me that they can't get a budget for game design because their administrators don't see it as being STEM. And when I first heard that, I thought it was ridiculous, but I can understand why people might think that, especially people who maybe didn't grow up with games or who have never really engaged them. They don't quite understand, for one, how they're made, and for two, how they're consumed and kind of what they mean to the end user. But I definitely feel that games fall under STEM very heavily, and for that reason, we feel it's important to kind of push that into education, to sort of engage students with this kind of all-in-one solution to STEM, so they can be prepared for either higher education or for the job world, the workforce. So what I want to do is show you one of the tools, well, probably my favorite tool for game design, which is called Unity 3D. I'm just going to do a very quick demo. This won't take very long, but Unity 3D is a game engine. Now, a game engine is basically, think of it as a software platform that helps you make a game. It's almost like if you use Photoshop to edit, pictures, or if you use Adobe Premiere to edit video and stuff like that. Unity is sort of the same way in that you build a game from the ground up, and it gives you tools that make it a lot simpler than just hard writing all of the code from start to finish, which is how people used to do it. But nowadays, with how complex games have gotten, pretty much everybody uses an engine of some sort to organize their assets and make things easy. So up front, you'll see Unity kind of looks like your typical 3D modeling software. You have the viewport here, which shows your scene. And what I have here is a something I've already done. This big old block of weird looking land is my terrain. So this is like my level. And then I have my hierarchy over here, shows me the different assets that are within my scene. I can get in close and check out what I have. Now, none of these are very polished. These are all sort of placeholder objects that I have. But what this guy is right here is a first-person controller, and this functionality is actually built into Unity by default. You don't actually have to program any sort of first-person logic. They have a preset script you can throw onto objects that will give it first-person abilities. So within Unity, you can play your scene to sort of see what you've got already. So what I have right now is I have like a light source on my sun, I have my landscape, I have a character I can move around, I have this little box here. My guy can shoot fireballs and hit stuff, including the box. And the box has physics applied to it, which I was talking about not long ago. Of course, the physics on my physics aren't exactly great with this guy. But within Unity, it's very easy to bring in assets. It's very easy to give these assets behavior. If I look at my first-person controller here, which is my little capsule guy, and he has the camera applied to him. Over here on my right, this is what they call the inspector. This is where basically all of the things that make up your asset, this is where it's at. So if I look at my first-person controller, it has a transform object attached to it, and all a transform is the XYZ you see here, so I can move it in 3D space. And then it has a couple of scripts attached to it, like a mouse look script and a character motor script, FPS input controller. All these different scripts basically serve to create the functionality so that when I play my game, I can actually walk around and look around with my character. Now, these scripts specifically come with Unity by default. I did not have to actually script these. So it's actually pretty cool because you can get started really quick. And if you are wondering about the script, or how they actually accomplished it, you can just open that script up in MonoDevelop and see it. Now, MonoDevelop is Unity's, what do you call it, IDE, I think it is. This is where you do the programming in Unity. Now, supposedly you can use your own IDE if you want. MonoDevelop's pretty cool though, because it natively recognizes Unity's own methods and classes that are specific to Unity. Now, what I mean by that is, let me see here. So if I'm looking at my projectile script right now. This is actually JavaScript, but it's a very modified form of JavaScript, because in JavaScript, for instance, this rigid body class here, this is not native to JavaScript. This is specific to Unity, but but MonoDevelop actually recognizes this as a valid class because it's from Unity and it has Unity's API built into it. So what I like about it is it just makes it a lot easier for you to sort of use kind of easier terminology to get what you want out of it. But at the same time, I'm still having to understand the basic syntax of JavaScript to make this work. So I really like the way Unity handles the scripting, and I feel like it's very easy to understand, and I think that's important for students, especially say in high school, who maybe are just starting to learn how to program, because programming can be one of those things that, sort of like math, it can be very intimidating for a lot of students, but I feel that the easier it is to digest something as far as math or programming goes, then the more likely it is the student will not be intimidated by that. And what's great with Unity is that their API, oh, where am I at? Here we go. They have an API reference that is extremely comprehensive and it's very easy to access. Pretty much if you have any question about what something is in your script, you know, like if I want to find out what a rigid body is, I can just look in their API reference and just look for like rigid body, and then I can click here and it's going to tell me all the descriptions. It's going to tell me all the different variables applied to that class, all the different functions you can have. And if I want, you know, maybe I want to look at what's the add torque function do here, and they give you examples of how you can actually use the add torque function, and it gives you complete description of everything. So it's extremely well documented, which kind of drives me to another point about Unity, is that there are so many resources to not only learn the program, but to kind of get support for the program. I mean, just by going to their website, you can find out pretty much any information you might need. But going back into Unity, I want to show some of the what do I want to call it? Cross-functionality, I guess I would say, between different programs. So part of your big workflow in games is going to be, you know, importing assets from different software such as Maya or 3ds Max or Photoshop, Pro Tools, whatever you might be using. Unity is very easy in managing all of this. Now my project, I got a whole bunch of stuff in here that I don't necessarily use, but my assets list here inside my project, this is all the stuff that's available to me in my Unity project. Now, I have a couple of these different models here. These are all these are all rigs that came from Maya. Now this is just like a default Maya file. It's an FBX file that I exported. I can literally drag and drop the FBX file into Unity, which I'm not going to do because I've already got 7 instances of it in here. But say you have the FBX file like on your desktop, I can just drag that, pull it into my assets, it's going to throw it in here, and it's going to be usable within my scene, and you can then just drag and drop the asset in here. I'll have to scale him up a little bit, come in too small. It's because I don't know how to model anything properly, so I'm very bad at 3D modeling, so I'm using the default Maya model that this gives me. So like I can import that guy pretty much straight out of Maya once I export the FBX file. And better yet is that when you export that FBX, it's actually going to export the animations with it. So you'll have animations at your disposal, and Unity has what's called animation controllers, where you can basically add an animation controller to an object, and you can tell it when to play a specific animation. So if you say my character moves forward, I want it to play this animation. My character moves backwards, it plays a different animation. Unity has a built-in controller that you can script all that functionality in. Well, it's not actually scripting. There is no programming involved in that aspect of it. You might do some programming to fine-tune it, but overall it's basically like a workflow. This is an animator controller, and mine's not set up properly, but you basically have like different functions that you would link together based on what your character is doing and what animations you have available to you. Let me get back to my scene. So one character I do have an animation for is this weird robot guy. Let me bring him in. So this guy was actually given to me from the guys who developed Poser. This is a Collada file, a DAE file, and they developed this, and they actually wanted me to use it for a demonstration. But this guy has an animation built into him, and I brought him straight in. I grabbed him straight from the file and just dropped him into Unity, and if I play this, he should be dancing, I think. Yeah. So this big old robot, I mean, this was literally me bringing the file into Unity, just throwing him into the scene, and his animation's automatically playing. Now this is like a static animation that's attached to this specific character, so when I bring him in, this is what he does. He just does his dance. But you know, you could go as far as to add an animation controller to him and say when the user does something, that's when the guy actually dances. And it looks like he broke. He just stopped dancing for some reason. Anyway, so animations and 3D models pretty much integrate seamlessly with Unity. When I was talking earlier about architecture, I like to talk about, because a lot of the individuals we deal with were from CAD departments or engineering departments at schools, and a lot of them use architecture software, and they're interested in using something like Unity to kind of take their stuff to the next level. I have a couple models here that were from Revit, and I'm going to drag and drop this guy in here. Now, this model's pretty rough, but what this guy is he was actually from Revit. Whoa, I lost it. Oh, there we go. And this is actually the default project that like comes with Revit when you're trying to learn the software. So I just grabbed that and imported it into Unity. And so the model comes in fully intact. The only thing that is not intact here are the materials. Like you'll notice the roof is gray. It doesn't have the right material applied. These windows, well, these are supposed to be windows right here, these kind of gray panels. They don't have the proper texture applied. Now, supposedly that's because Autodesk material libraries for like their newer versions are not fully compatible with Unity at the moment, but usually the workaround here is to throw it inside of like 3ds Max or Maya and then export it, and it will maintain all your materials. But for the sake of this, I'm just trying to sort of show how you can bring this in and then manipulate it. I need to, there we go. I need to scale him up a little bit. So when you import this model, and he's kind of on top of everything. There we go. So when I import this model, here, let me see it in the list. What I have checked here on the list for my asset is to generate colliders. Now, colliders are used to basically determine when something is touching something within Unity. In game design in general, game collision, that's pretty much what the concept is. It's when one object crosses over another object, and then what do you do when that object touches that object? So for instance, if I play my game to sort of give you an understanding of collision, when I touch my box, I can't pass through it. That's because my box has a collider attached to it, and so does my character. Likewise, when I shoot my fireball and I hit the box, you'll see that the box sort of flies away and my fireball explodes. If I just shoot my fireball into the air, it doesn't explode. But once my fireball touches something like the ground, it explodes, and that's all due to collision. Now, what's cool in Unity is that collision is incredibly easy to handle. There's literally a, like if I click my robot guy here, yeah, there's literally a list of colliders. Like you can say I want a mesh collider, and that's going to automatically put a collider around my robot guy, so that now when I play my game and run to my robot, oh no, that didn't work. It's probably because I didn't tell my character to stop when it touches him. But once I have an actual mesh collider on my robot, I could then script some behavior within the robot and within my first-person controller that says if my collider touches a different collider, then I can't pass through that object. So if I look at my big old building that I imported here, I told it to generate colliders by default when I imported it. So what that does is it makes it so that I can't actually pass through my building here. I'm trying to walk through it and I can't. Wow, my building's way small. I need to scale this up. But what you could do, whoops, wrong scale. Undo. But so for instance, hold on, let me scale this up real quick. So if I wanted to, I could say grab specifically this door object, and my guy can't walk through that, but since there is a collider attached to this now, I could script this object in such a way that when my character approaches that door, the door will open up. Now, for the sake of time, I'm not going to do that because it would take me a little longer than I want to do, and my object's floating in the middle of the air and I can't get onto it. But for now, I'm going to go ahead and just remove that door and move my building back so that I can actually get onto it. Actually, I'll move it over here and then rotate it. Okay. So I say remove my door, and now my character can sort of walk in here and check out the house. And so all my geometry from Revit is all intact and it's all in here. I have all my doors, I have my stairwell, I can walk around, and there's colliders generated for everything in here. So like I can't walk through this, this railing. I stay on the steps, I don't fall through them. I can jump around, move around the house. And of course I have doors in here that I would need to delete to walk through, but this is just to sort of show, you know, that architecture demo I showed you earlier. That's pretty much how they did it. They brought the FBX model from Revit, they threw it into Unity, and of course they spent a lot more time on it than I did here. But they were able to create the first-person controller that allows you to sort of move around the house here. And if you remember, they had that graphical interface on the left side that would let you jump from like the roof to the lower floor, the first floor. You know, they would designate certain areas of this model to be, you know, so up here I would be able to, within Unity, designate a certain collider, what they call a trigger. I would be able to say, once my character passes onto this floor right here, this will be a trigger as the second floor. And then you could make a fast travel function that says when the user presses the second floor button, teleport the character right here to this location. So that's kind of the idea behind architecture in Unity. The idea behind me showing this is just kind of give you an idea of what Unity looks like and sort of how it works. You know, there's a lot to learn with Unity. I can't really go over all of it within 10-15 minutes, but the great thing with Unity is that the software is free up front. And what that means is if you're at all interested, I recommend you just go to their website, unity3d.com. I think it's, yeah. And then up here at the top right, there's a download button. You can get Unity for Windows, and you can also get it for Mac. And where's the Mac download? I forget. Do I just hit download? I don't know where the Mac download is. I forget. There's a Mac version. Probably best to just look for it on Google, say Unity 3D Mac download. But it's free to get up front. So you just download it and check it out and mess around with it. See if it's something you like. And if it is something you like, if you're an educator, if you're looking to put it in your classroom, you know, at Studica we offer really cheap discounts for students, faculty, and education. So you can contact us and we can talk to you and see what your needs are and see how we can help you out. But yeah, just check it out and mess around with it for a little bit and kind of see if it's something that you might want to use and you like. What I want to talk about as well, and this is something kind of new that I've gotten from Unity, is that they're working on a list of standards for, they're working on a list of standards for education. And this is pretty big. This is very interesting, and what they're looking to do is create kind of the framework for curriculum to be developed. And so what they've done is applied a table of contents that sort of covers all these different aspects of game design. And then what they have done is they break it down into what standards does this actually address. Now currently this is a draft. This is not final. This is very early, not complete stuff, and they're still working on it very heavily. But some of the standards they're looking at are Common Core. They're looking at IEETA, technical standards, 21st century skills. They're looking at STEM clusters, and they're adding more and more as time goes on. And each of these different units, they're telling you which standards these address. Now, T21C2, I don't know what that is off the, oh, well, it looks like a 21st century skills standards according to the rubric here. But they have an appendix near the end of this document that basically tells you what each of these standards are, what the purposes are, and how that fits into this sort of framework that they have for Unity and game design. Now, basically what this is used for is like a guiding hand for the development of curriculum. So you as an instructor, developing curriculum can take a lot of time, but it's very important. And with game design currently, there's really no widely adopted curriculum, and there's kind of there's really no understanding of what standards are addressed really. It's all kind of guess and check, or you'll have to do that research yourself, but Unity's taking the initiative to actually do all this themselves so that this information is there for instructors, so that you don't have to worry about whether or not I'm meeting Common Core standards, am I meeting STEM standards. They're going to make sure that you are, and that you have a sort of direction that you can base your curriculum that you might want to develop on. And they have sent this information out to a couple hundred people actually for review to make sure everything checks out. And so far they've heard back from, I don't know, like 50 or 60 or something like that. So there's still a lot of review going on. There's still a lot of work in progress, but this is something that's coming down the road. And to me, it represents a really big opportunity for educators as far as game design goes, because it kind of alleviates a lot of that busy work of cross-checking standards and stuff. You don't have to worry about that. You can just use this as a basis to develop the curriculum that you want and actually get to teaching your kids the skills that they need. And on that same note, there is a curriculum framework that is kind of in the works here. And again, this is very rough draft. This is very early stuff. But what their curriculum, what they're looking at, the way they're sort of breaking this down, is that they want it to be incredibly flexible. They want teachers to be able to adopt the curriculum however they want. It's not going to be this sort of thing that you have to do everything the way we tell you to in the curriculum. It's more going to be a suggestion or a sort of guideline for you to kind of reference and develop your own sort of style around. And what they have it broken into is basically units of study. So I'm looking at Unit 1, which is Introduction to Game Design. Again, this is all draft. This stuff is not final by any means. There's a lot of work that needs to be done here. But this is Introduction to Game Design. It shows you the different standards alignment. So, what standards am I addressing with this specific unit? So we see Common Core Learning Standards for literacy. And then they have an overview of what is this unit going to be describing in general. Specifically, this one is related to the basics of game design, such as what genres are there, what is game design, what's game theory, what kind of tools are available for me to use. It tells you what the major topics are in this unit. It's going to be a Sorry. There's going to be a game design overview, game genres, game editor introduction, game element overview, so on and so forth. And then they break it down to what are the learning targets, and learning targets are basically just general statements of what is the unit going to accomplish for your students. The idea here is to identify the learning outcomes for the students, what you can expect them to learn by the end of this unit. So for this one specifically, it says demonstrate a basic understanding of game design principles, summarize the purpose and function of various game elements, explore the Unity editor, and so on and so forth. Goes on. And then the entire unit's actually broken down. So these key topics that we see up here, the 6 of them, they're then outlined into different sections. So if we look at game and application design overview, we're broken down into what is game application, how is it created, what makes a game enjoyable, what are the game genres, game platforms. Then we have game element exploration, which will look at narrative formation, game design objectives. And so this is sort of the general direction that Unity's going with the curriculum as a framework. There's also activities and task recommendations, what you can have your students be doing. They also have resources and materials, which are basically websites and stuff where you can get free assets that you might need to complete something. So say you have an activity where your student needs to experiment with sound within their game. they give you resources for, license-free sound effects and music and stuff like that. So your students can just go on there, download it, and use it. No questions asked, no issues. In general, overall, what they're wanting to do is a sort of 3-track setup here with their curriculum, which would be instructor-led learning. So basically you lecturing students, giving them all the information they need. Then it would be student exercises, which is what it sounds like. Your students taking the knowledge that you're giving them and actually applying it within Unity and developing something. And then they're wanting to do a sort of capstone project, which would include a notebook for your students, where basically they, over the entire semester or year-long course, they would be keeping a detailed documentation of like design documents and stuff like that, that would go through a sort of submission and approval process, kind of the way that they do it within the game development industry. Now, what their end game is with the capstone project, I really don't know. I still don't know a whole lot about this. This is all just very preliminary stuff that we're trying to kind of get out there to show educators that there's something in the works here that is going to be very beneficial to you. And the thing I like to kind of drive home about this is that there's no other game engine that is focusing on education this way. Some of the big competitors to Unity are like the Unreal Development Kit, or say Construct 2, even like Game Salad and stuff, but they're all still focusing on commercial and independent developers, which is fine. I mean, that's where Unity started off too, but they're seeing the benefit in getting students engaged with game design, and they're trying really hard to push themselves into education in such a way that it's beneficial for you as an instructor and beneficial for your students, and it's very easy to implement. So basically, you get a lot more just support from the educational point of view from Unity, and that's where they're really moving their resources into. So these documents specifically, I can't give them out to anybody currently, but they are in the works and there should be published versions soon. And so whoever's on the webinar, we do have your email information. Once I actually get these finalized documents and get the okay from Unity to send them out, I'll be able to actually send these documents out to the attendees in emails, so you can have that and check them out. And if you're using Unity in your class, you can try and implement these resources and see how they work for you. So I think on that note, I'm pretty much done here. I want to open it up to questions, but in order to avoid feedback, I'm going to keep the microphone muted. So if you have any questions, feel free to use the chat menu to access the chat. It should be on your Join Me menu across the top of your screen. It should be the second icon on the left with the little chat bubble. If you have any questions for me, just let me know and I'll try to address them. Oh, it looks like viewer 10 was asking some stuff. I'm sorry, I wasn't reading the chat while I was presenting. Any programs for middle school students in particular? I saw Google has a coding system and a program called Scratch. I want to tie that into the science curriculum somehow. I mean, currently there's no official program for middle school. Typically with like Unity, we tend to recommend it more in the high school section. However, since Unity has implemented 2D functionality with their latest version, I do feel like it can fit into middle school, but I don't have any specific sort of curriculum for middle school at the moment. And as far as Google Scratch goes, I'm not too familiar with Scratch. I can't speak too much on that. Viewer 6 says code.org, his middle school curriculum ties into middle school science, so that could be a good resource, might be worth checking out there. But we do actually get quite a bit of interest about middle school. So, part of the standards and curriculum framework I showed you, Unity realizes that, and they're wanting to, that's part of why they're developing curriculum and stuff, so that there is a clear track for middle school, high school, university level, education. Okay, that's great. Scratch is developed at MIT, not Google. Do we have educators working with us on the development? I personally don't work for Unity. However, the people I've been talking to at Unity, they are working with different educators and professors. They're also working with people who have developed curriculum for other disciplines such as engineering and mathematics. Specifically, an individual by the name of Tom White, don't know if you're familiar with them. We've worked with them to develop curriculum for some of our other product lines like Fisher Technic. He's also kind of consulting with them. They've sent the information out to a couple hundred different people, including educators. So my hope is that, yes, different educators will be seeing this and providing feedback and working with them on it. So hopefully that turns out well. But it's all, to be honest, it's all a bit secretive. They don't tell me a whole lot of stuff. So they basically gave me the drafts and, wanted me to talk about it a bit. So I can't elaborate too much on what's going on behind the scenes there. Is there anywhere to share your Unity creations? So viewer 6, I'll get to your question right after this. Yeah, I actually totally skipped over all this stuff. My mistake. So there's multiple places. The first one I'll look at is the Unity Asset Store. So the Asset Store is what it sounds like. It's an asset store for Unity stuff, for stuff that you can bring right into Unity and use. Sometimes you'll get full-on games in here. Most of what this is are different assets that are used to create games. So let's look at this staff pick here, the Medieval Village. It does cost some money. So what this is basically a set of different assets that you can use to create a game. Now what it looks like we have here, and you can see the package contents. Let's see, they have different animations. So what we have here, like for instance, here's ground textures, TIF files that you can use for different meshes. You have different material textures that were all designs. Let's see, they have prefab trees. Prefabs are basically pre-made assets that you can just bring into Unity. They have different components about them. There's tree textures. It looks like it's still loading a lot of information. This must be a really large package. I'm assuming based on, so here's some more models. So you can kind of see down here, can I expand? Oh, there we go. You can see down here, they have kind of this weird bell tower thing. These are all just different parts of this package that you can purchase from Unity. Now, I know you're asking, is there a way to share your creations? This is kind of how you can do it. So say you have a student who designs like, you can even sell scripts and stuff through this website. So for instance, one of the popular ones is like artificial intelligence. Since that's kind of a really hard topic, there's some packages on here where you can download AI scripts and stuff like that, which make it a little easier for you to implement AI. But if you are a user and you have something you created in Unity and you want to, share it out there or even make some money off of it, you can throw it on the Unity Asset Store and sell that out. Likewise, in Unity, you can export your game out to like PC, Mac, and Linux. You can do iOS, Android, you can do Flash, Windows Store, 360, PS3. However, some of these other ones will require additional licenses to actually do. And then you also have to take into consideration any of the different platform fees and things like that. I know like for iOS, in order to develop at all, you have to pay them like $100 a year or something. So there's that to consider, but if you do have a game, you can export natively out to the web player and you can do like PC, Mac, and Linux. If you want to do these other platforms, you have to have the license for it. But yeah, it's really easy to just export straight out as an executable and then bring that other places. I won't do it right now just because it will take probably too long for it to build out, but like right here, I would just hit build and it will actually create an executable for me. I can just run that executable and it's going to be what I see here in my scene. So viewer 6, let's see, what's your take on how approachable and easy this is for high schoolers? I mean, my take personally, I was in high school not too long ago. I was taking programming courses about, I would say, years ago in high school, and at that time there was nothing like Unity available. Everything we did was not command line, but it was all programming. It was all from the ground up. It was public static void main, and then writing all this stuff out in code. I would have, at that time I was in that class, I would have killed for something like Unity. I mean, when I first grabbed the program, I was amazed how simple it was to use. It's very intuitive. I mean, there's still scripting and programming involved, but it makes all the other parts of the game design very simple, like throwing in an asset or creating a terrain or adding collision and stuff like that. The amount of scripting you do is pretty minimal compared to what you were doing, say, 10 years ago. Now, as far as the average high schooler goes, there's going to be a learning curve, but I don't think it's going to be extremely difficult. Especially kids nowadays seem to grab onto software very quickly and easily. I think when they see the program, it's very easy for them to kind of know what's going on. I think most of the learning is going to be the behind the scenes stuff. It's going to be the actual scripting, where they're going to have to understand the programming. They're going to have to learn the syntax and all that stuff. I think that's where the bulk of the actual learning comes in. But the thing with games and game design in general is kids really love this whole, this kind of whole, what do you want to call it, industry or discipline. They really like video games, and I think when they can visually sort of see what the code that they're writing is doing within their scene, I think that gets them really motivated and encouraged to keep going and to learn new things. I mean, just my own anecdotal experience when I was in high school and taking programming, we had probably 34 people in my class. Every single one of them was in there because they wanted to make games. None of them wanted to make an operating system. None of them wanted to make software like Facebook. They wanted to make a video game. They all grew up on Legend of Zelda and Mario. Like, that's what they wanted to do. And sadly, a lot of them got really turned off because everything was done in a code editor. And, it's a lot harder to visually see that kind of end game there when all you're doing is staring at lines of code all day. You find it okay to teach all the foundational programming concepts, if loops, methods, functions, etc. I think so. Now, that's something that I think, depending on your approach that you take, you could do it differently, but I think it's, let me see here if I have any decent examples. Well, where's my scripts here? Okay, here's my scripts. Let's see. Switch, I have a, that's not a good one. So for instance, and this is a very rough example, but the script I have here is my projectile script. This is what I use to actually create the little fireball that comes out of my character when I press the left mouse key. So, this shows you sort of how you can define the variables up here outside of your actual function. And this is JavaScript, so the syntax is JavaScript, not C#. That's another thing. Unity can use C# JavaScript and Boo. Supposedly, and I haven't experimented with it, but you can implement C++ scripts into it, but I've never actually tried or done that. But for instance, here's a pretty straightforward, simple if statement that says if the input.get button down is fire 1. What this is saying is if my left mouse button is pushed down, then I'm going to execute something. And some of this stuff looks kind of confusing. I understand that, but that's because I'm trying to spawn an object and everything. But you can go to something pretty simple, like say like a damage script, where if something gets touched in my scene, then it's going to run a damage function. Or here's a health script where if my HP goes to 0, then something explodes. Or I even have a very basic regeneration function where the HP is incremented by 5 by 5 every like 2 seconds or something. I don't have any examples of while loops or any loops of that sort. But I do think that, especially if you're starting off with a very basic idea, if you were going to throw your kids right into like okay, make a first-person shooter with like something that you shoot and hit objects with, they're not going to grab onto that immediately. You know, you would want to start off with like an empty scene or something and have them, you know, have them create like a block or something, and you know, say like a cube, and create like a cube here. You'd want to have them do this, and then maybe smash this down into some kind of plane that you could put your characters on, and then, you know, say drop something else onto the scene and have them create a collider for it so that objects don't fall through. And then you could say, what kind of functionality do you want to give like the sphere, you know? Do you want the sphere to, say, destroy itself after 3 seconds? You could go with a script very basic like that at first, and that would be pretty easy to program within Unity. So to actually teach fundamental programming, I definitely think it's there. It might be easier to just do it like command line up front, you know, the traditional hello world sort of introduction that most students get. You know, how do you make the computer say hello world on the command line? Stuff like that might help them understand the basics better. But it really just kind of depends how creative you want to get with Unity. I mean, the program's very powerful and there's so many different functions involved. I'm sure that there's a way you could come up with something very basic to teach them those basic concepts there. Slightly worried about the overhead learning about the environment. It's like VB on steroids. Yeah, I mean, it's kind of the give and take of any software platform, you know. Anytime that you have to learn something new, there's going to be that learning curve involved. You know, I'm not going to deny that for sure. It's going to take a little bit to at least understand, you know, what is the hierarchy here? What is my inspector showing me? And what are all these different things here in the inspector? You know, I definitely understand that. But as far as a tool that is very easy to actually do game design with, I feel like this is one of the best tools out there. You know, give or take some of the overhead that might be required to learn it. And generally, this is why we do recommend Unity for high school or above, specifically because it's, you know, you want your students to have a certain level of mathematical knowledge, and you want your students to be able to engage the ideas of, or at least those fundamental concepts of programming. Not that they have to know the programming going into it, but you want to be able to be sure that they have the capacity to understand it. And so, you know, there is a little bit of overhead, but once you know how the program's running and once you kind of know what you're doing in the interface, it becomes very easy to just start drag and dropping stuff and then writing out your scripts. You know, scripting is probably the part that takes you the longest, just because you're gonna try something and fail a couple times before you get the right, you know, line of code going. Is there any other questions? Not getting anything right now. I'm gonna throw my email, in the chat there. If anybody needs to follow up with me or anything, or has questions, or is actually interested in purchasing, we can get you great prices. Just let me know. Will I do another? Yeah, I actually have another one of these. When is it? The 16th, I believe. Yeah, let me see if I get the link here. The 16th at the same time. Oh, I actually am on a different computer. I don't have the link. I'm actually in California, Central California, so I think most of you are about 3 hours on me. Yeah, I am recording this. It will be on our YouTube channel. Our YouTube is at, I think that's it, Studica USA. I have a couple other stuff on there. Pretty much though, my next webinar is going to be a lot of the same information. So if you've been to this one, you probably don't need to be at the next one unless you're curious about questions other people might have. But hey, if you want to show up, more power to you. I'm not going to complain. So, what do you mean by ideas exactly? Well, for the sake of these webinars, I'm pretty much focusing just on Unity. Like, we have other stuff that we're involved with, like Game Salad, but I don't usually do webinars on that, so. Yeah, no worries. So if there's no other questions, I think I'll close that out. One last resource is our phone number in case anybody wants to get in touch with Studica, talk about our offers. You can reach us at that number. And again, my email address, markp@studica.com. You can reach me there. So yeah, if you need any follow-up or you have any questions or interested in anything, just let me know. And I think with that, I'll close this out unless anybody has last-minute questions. Going once, going twice. All right, no questions. Thank you everybody for showing up. I hope you all have a good day, have a good holiday. And thank you.